Okay, imagine this. You ask an AI to plan, like the ultimate world tour. Taylor Swift and BTS together.
Wow, okay. Logistically, that's a nightmare.
Exactly. Optimal jet routes, venue capacities, customs, everything. You need it perfect. But here's the twist. What if the AI nails it, but the steps it took?
Well, they make no sense to us, like totally alien logic.
That exact idea, AI genius through its own invented logic, that's what we're digging into today.
Yeah, we're looking at this huge paper, came out in Nature, September 17th, 2025. It basically pulls back the curtain on this model called DeepSeek-R1.
Right. And the mission, our mission here, is to understand how this model from a Chinese firm got so good at super complex reasoning.
Like advanced math coding.
Yeah, without humans explicitly teaching it how to think step by step.
And the big reveal, the teaser. They built this top-tier reasoning AI for way, way less money than the big players.
Uh-huh. The secret sauce seems to be this thing called self-evolution, using reinforcement learning, or RL. And why should you care? Well, I mean, this tech, when it was first announced back in January, it actually caused the U.S. stock market to dip. Seriously.
Yeah, the news reports confirmed it. So this isn't just some lab experiment. It's got real-world financial clout, real societal ripples.
So let's set the stage. AI reasoning, math, logic, coding, that's always been a tough nut to crack.
Oh, absolutely. It's kind of the holy grail, getting AI to think logically, flexibly.
Mm-hmm.
It's a long-standing challenge.
And we've had methods like chain of thought, COTI, where you prompt the AI, let's think step by step.
Right, and COTI was a big step forward. It forces the model to show its work, basically.
But it has downsides, big ones.
Huge ones. First, COTI absolutely relies on tons of human examples. Humans have to write out those perfect reasoning steps for the AI to learn from.
Which sounds slow and expensive.
It is, and it bakes in our human biases, our ways of thinking. And maybe the biggest thing, it caps the AI's potential. It can only be as good as the human examples we give it.
Right. It can't explore weird, maybe better non-human ways of solving the problem.
Exactly. It's like, imagine teaching someone Blackpink's choreography. You show them every single move perfectly.
Okay.
They might get really good at that specific dance. But with COTI, you're not teaching them how to invent new dance moves or maybe win a dance battle using totally unexpected styles. You're just teaching replication.
Gotcha. So the DeepSeek AI team over in Hangzhou, China, they had this radical idea.
Pretty controversial at the time, yeah.
Yeah.
They basically asked, what if we ditch all that human hand-holding? What if we just use pure reinforcement learning?
Just reward the right answer, forget the steps.
Sorta, yeah. Let the model figure out the how entirely on its own. This led to DeepSeek-R1.0. That was the first version.
That one's 0, okay.
So they took their base model, DeepSeek V3 base, and applied this RL technique called GRPO, Group Relative Policy Optimization.
GRPO sounds technical.
It is a bit, but basically it's a smart way to make sure the model learns real strategies, not just finding loopholes to get the reward. The key thing, the only reward signal was, did you get the final answer right, yes or no?
Nothing about how it got there.
0. No points for showing your work, no penalty for weird steps, just correctness.
I can see why people were skeptical. Wouldn't it just guess or find some weird shortcut that isn't really reasoning?
That was definitely the fear. They skipped the usual steps, supervised fine-tuning, where you explicitly teach logical steps. They wanted to see if reasoning could just emerge.
So let's use that soccer coach analogy you mentioned. COTI is the coach yelling plays from the sideline, right? Pass here, shoot now.
Exactly. Dictating the process. DeepSeek AI with this pure RL approach was like the coach saying, look, I don't care how you score, kick it, head it, bounce it off the ref. Just get the ball in the net.
Okay. Reward the goal, not the fancy footwork. So what happened? Did the AI just flail around?
That's the amazing part. No. When they trained DeepSeek-R1.0 this way, only rewarding the final correct answer, it started developing really sophisticated behaviors all by itself.
Like what?
Things like self-reflection, checking its own work, trying different strategies dynamically. It actually started generating much longer answers, sometimes hundreds, even thousands of tokens long.
Why longer?
Because it was internally refining its own logic. It was thinking, checking, rethinking, trying to guarantee that final answer was right. It wasn't just spitting out the first thing it thought of.
Okay, and this leads to the aha moment thing you mentioned, the part that sounds almost human.
Yes. This is wild. The researchers looked at the words the model was using in its internal thought process during training.
Like its scratchpad.
Exactly. And they noticed this sudden, really clear spike in the model using one specific word. Wait.
Wait, Like WAIT?
WAIT, wait.
Yeah.
Yep. During its reasoning, it would generate stuff like solving for x. Okay, so x equals, wait. That feels like an aha moment. Let me double check that. Let's reevaluate step by step.
Whoa. It taught itself to pause and reconsider. Like a student catching their own mistake.
Pretty much. It's like emergent self-monitoring. And this wasn't programmed in. It just happened as a good strategy for getting the final answer right more often.
Okay, that's genuinely surprising. Did this translate into actual performance, like measurable results?
Oh, yeah. Big time. So the paper in Nature by the DeepSeek AI team in Hangzhou, China, lots of authors. On that one, they benchmarked it rigorously.
What did they find?
On the American Invitational Mathematics Examination, the AIM 2024 version, which is a really challenging high school math competition,
Right.
DeepSeek-R1 Zero's score, its pass at one score, went from about 15.6%
Which is okay, I guess.
to 77.9%.
77.9. Wow, how does that compare to humans?
That's the kicker. The paper notes this score greatly surpasses the average score of actual human competitors on the AM.
So this AI, teaching itself, became better than the average talented human mathlete.
On this specific, very difficult test.
Yes.
And it wasn't just math. It also showed huge gains in competitive coding, graduate-level biology, physics, chemistry problems.
So it's not just a one-trick pony. It developed general reasoning skills.
It really looks like it. Robust, general reasoning.
Yeah.
Just from being rewarded for the right answer.
But hang on, the performance is amazing, but you mentioned the cost was the real shocker, the thing that spooked the stock market.
Exactly. That comes from the accompanying Nature News piece by Elizabeth Gibney. She highlighted the economics. First off, DeepSeek-R1, the final version, it's an open weight model.
Meaning anyone can download and use it.
Basically, yeah. The core model weights are public. It's been downloaded like almost 11 million times already on Hugging Face.
Okay, popular. But the cost.
The cost to train the reasoning part that jumped from 15% to nearly 78% on AIM for the R10 version cost the equivalent of just US $294,000.
$294,000. That sounds incredibly cheap for AI.
It is. Now, that's on top of the estimated $6 million to build the base model, DeepSeek V3. But still, compare that $294K for the reasoning breakthrough to the tens, maybe hundreds of millions people estimated cost to train rivals like GPT-4 or Claude.
It's pennies on the dollar.
They primarily used NVIDIA's H800 chips, which were available in China at the time. But the main thing is the method. Pure RL seems way more data and compute efficient for teaching reasoning than massive supervised fine-tuning.
So this completely changes who can build cutting-edge AI, doesn't it? It's not just the giants anymore.
It definitely lowers the barrier. If you have a solid base model, this suggests you can add powerful reasoning capabilities relatively cheaply. It challenges that whole bigger is always better compute resource race.
There's always a but, right?
Yeah.
R10, the super smart math genius, it wasn't perfect.
Not at all.
Yeah.
It was, like you said, a crude genius. Because it was only optimized for the right answer, its internal reasoning steps were often a mess, hard to read. And remember, the base model knew English and Chinese. So R10 would sometimes just mix languages mid-sentence in its output. Kind of like, the answer is 42. Gibberish for most users.
Right. Not exactly user-friendly, so they had to polish it, teach the genius some manners.
Exactly. That's how we get from R10 to the final product, DeepSeek-R1. They used a multi-stage process. First, more supervised fine-tuning, SFT.
Wait, I thought they skipped SFT.
They skipped SFT for reasoning, but after the reasoning was baked in by RL, they used SFT with non-reasoning data, just general text, Q&A stuff, to teach it better communication skills. How to write clearly, be conversational.
Ah, okay. So fix the language and readability after the core logic engine was built.
Precisely. Then, a second RL stage. But this time, the rewards weren't just about the right answer. They used rewards based on human preferences, trying to make it more helpful and harmless, the standard alignment stuff.
So the final DeepSeek-R1, was it even better at math and code?
Only marginally. The big reasoning leap happened with R10. The main improvements in the final R1 were in general skills, following instructions better, being nicer to talk to. They saw like a 25% jump on benchmarks like AlpacaIFAL 2.0, which measures user preference.
Makes sense. You need the smarts, but you also need it to be usable and safe.
Right, and the authors do mention ethical risks. Better reasoning could potentially help generate more dangerous content, like, more detailed plans for bad stuff. But they say its safety levels, with their control systems, are comparable to models like GPT-4o.
Okay, so let's wrap this up. What are the big takeaways here? You called it the learning learner.
Yeah, I think there are three main things. First, self-correction is key. This whole thing basically proves LLMs can figure out complex reasoning, like checking their own work, all by themselves, if you just incentivize the result.
Okay, number one, AI can teach itself to think better if you just reward the right answer. What's two?
Two, efficiency wins. Pure RL, at least for reasoning, seems way cheaper and faster than the old way. It blows the doors open for smaller players, potentially.
Right. Disrupts the resource advantage of big tech. And number three.
Three, a new horizon. This method could work for any task where you can clearly tell if the answer is right or wrong, no matter how complex the steps are for a human. If a verifier can check it, maybe RL can solve it.
And the researchers, they think this is the future, right? Not more human labeling, but better ways to verify answers and enough compute for this RL process.
That seems to be their bet. They're looking at integrating tools now, like search engines, calculators, compilers, directly into this self-learning loop.
Imagine an AI that teaches itself reasoning and how to use Google to check facts in real time.
Exactly. That's probably the next frontier.
Okay, so that leaves us with a final, maybe slightly unsettling thought to ponder. If AI can teach itself complex reasoning, optimizing just for the right answer, and maybe developing logic that feels totally alien to us, are we ready for that?
Ready for machines that solve huge problems, using thinking that might be fundamentally different, maybe even superior to ours.
Yeah, something to chew on until our next deep dive.